This lesson is about solving for unknown values on a right angle triangle. So a right angle triangle is one that has a 90-degree angle in one corner. We often represent that with this little square right here. That shows us that this is 90 degrees. Okay, so that's showing us that we have a right angle triangle. Now, I want to be able to look at labeling this right angle triangle so that we're all on the same page in regards to talking about the sides and the angles. So we talked about the 90-degree angle. Now we're going to talk about the side opposite that angle. Okay, and we're going to represent that with a C. Our C is often referred to as our hypotenuse. Okay, so we would say the angle across, we give it a capital C. That's our 90 degrees. Now, one of the other sides would be our vertical. Okay, and we're going to represent that with an A because that represents our altitude. And the angle opposite him, which is this right here, we would give a capital A. Now our last side, we would represent with a B. Okay, and B is equal to the base. And then this angle opposite B would be the angle B, okay, opposite side B. So here's our labeling basically for our right angle triangle. We have our sides in lowercase, and then we have our angles in uppercase. Okay, and we're going to want to know what those are when we get into trigonometry, but also in finding sides. Okay, so the first thing we're going to do is talk about the angles quickly. Okay, so if I have a right angle triangle and I know that one angle is 90 degrees because that's what makes it a right angle triangle. Okay, so I have a triangle here. I know this one right here is 90 degrees. Okay, so if I have 90 degrees, the other angles, or the non-90 angles, are complementary, which means they always add up to 90. So if we go down to angle A, which is right here, and we say that that's 30 degrees, I know that angle B has to equal 60 degrees because they have to add up to 90, so 60 plus 30 is equal to 90. So Pythagorean theorem states that in a right angle triangle, the hypotenuse squared, so C squared, is equal to the sum of the base squared. Okay, so our base squared plus our altitude squared. So that's those guys there. So what we basically just stated was our altitude squared plus our base squared is going to be equal to our hypotenuse squared. Okay, now we're going to be having to solve for one of these values singularly. So I'll give you those derivatives of those formulas coming up. But we have to be able to manipulate this formula for any unknown side. And we must know two sides in order to find the third. So if we were going to put some values in here, we could have our altitude as, we could state it as 12 centimeters. And we're going to have our base as 15 centimeters. So now we got to solve for C. So what is C going to be? So if I start putting these values into this formula, I end up having 12 squared plus 15 squared is going to equal my C squared. Now I have to get this squared out of here. Okay, I can't have my answer being squared. So I'll review what we do with squaring. In order to get rid of the square, we actually have to square root this side, which gets rid of the square so that I'm isolated just for C. But whatever I do to this side of the equation, I have to do to this side as well. So my new formula becomes the square root of 12 squared plus 15 squared, and that will give me C. Now if you're putting this into your calculator, make sure to put brackets around here. So then when I enter that in my calculator, my C would become 19.209. So that would be my value right here. Okay, so we've just used Pythagorean theorem to solve for an unknown side. Now we can rearrange this formula if we're given the hypotenuse. Okay, so we'll do a quick example of that as well too, because we're going to have to be able to rearrange this formula. Okay, so in this example, I'll even talk about the exact same we just had. So we said that our hypotenuse was 19.209, and we knew that our side A was 12. Now let's just say I'm looking for B. Now I know we know B because we just did this, but if we didn't, we'd have to rearrange this formula. So we'd start with A squared plus B squared is equal to C squared. Well, I have C squared, or I have my C, and I have my A, but I'm looking for B. So I have to isolate for B in order to solve for it. So if I have A squared plus B squared, what I have to do to get rid of A squared is I have to minus by A squared. That gets rid of the A squared over here, so then I'm just left with B squared is equal to C squared, but because I minused A squared over here, I have to minus it here as well. So here's my new formula to solve for B. Again, I have to isolate B singularly, so I have to take the square root of B to cancel that out. So I have to take the square root of this side as well. So my new equation becomes the square root of C squared minus A squared is going to give me B. B is equal to the square root of 19.209 squared minus 12 squared. Okay, if we put that into our calculator, again, make sure we're putting these brackets in. Otherwise, it's just going to take the square root of the first number. So we put that into our calculator, and we find that B is equal to 15. Okay, so we're going to have to be able to work back and forth through these formulas. Okay, basically the three derivative formulas we're going to have to get out of Pythagorean theorem are the original one of A squared plus B squared is equal to C squared. Then we have C squared minus A squared is equal to B squared, and C squared minus B squared is equal to A squared. And obviously we would have to isolate those by taking the root. Okay, but that's our formula that we can use to find any unknown side if we have two sides.